All right, remember, your goal is to make sure I'm talking. Thank you. So, your goal is to make sure that you have a piece of paper. So first thing, I will make sure that you're gonna use a matrix system, which is centimeter rather than things. There's a few ruler back there. If you have your own ruler, anybody have their own ruler in this class? No? You have your own ruler?
I brought mine today.
Thank you.
Why?
Yeah. That's a centimeter. That's kind of long, but okay.
Pretty average.
You're gonna whack somebody in the head.
Okay, but you want to know, buddy?
Okay, so your goal is to have this paper, and you're gonna measure it. You're gonna measure this piece of paper, and hold on, let me go to the paper.
He did a thing where to pour a cube, and then the cube had to be a certain volume.
Yes. How do you know? You already hear somebody talking about it, right?
My brother was very good at calculus. Now he's a farmer.
That's so cool.
Yeah.
And actually, in the future, farmers probably gonna make more money. So except they're gonna kick out all the illegal immigration, so there's nobody gonna pick up the vegetable.
That's his job though. He goes and collects the vegetables.
I don't know. Vegetable might become very expensive if that happens. But that's the thing. There's a pro and con, but
That's what my brother does. He picks the vegetables. He works for a small farm and already.
all right. Shh. I cannot talk over you guys again. I hear a lot of conversation besides me. So there was a scissor over there. There's a 3 pair of scissors, so you guys can already share. If you have your own scissor, that'd be awesome. Also, somebody let me borrow a scissor, so there's total 4 pair of scissors. So basically, what you're gonna do is you're gonna take this paper and you're gonna measure the length in centimeter, not in inches, right? In inches, it's not gonna work. So in centimeter. Now we're gonna cut off this corner, and you're gonna cut it off, and you're gonna decide how big you need to cut off. Now, pay attention. Each cutoff is gonna be exactly a square. Okay, it's gonna be exactly a square. Somebody's out there. Okay, so you're gonna cut off here, you're gonna cut off here, you're gonna cut off here, and you're gonna cut off here. Now, once you cut off, it should look like something like this. I'm gonna copy and I'm gonna paste here. And then what happened is the cutoff is gonna become like this. Let me erase it so that way the cutoff is gonna be like something like this, right? But they have to be exact same size though. One requirement is they have to be exact same size. And once you cut off, then you have this length here. This becomes edges now. And what you're gonna do is you're gonna fold it upwards along the dotted line here. You're gonna form a shape called rectangular prism, and it's gonna be without top. Your goal is to find out how big of the square you have to cut in order to have the largest volume. So the largest volume of rectangular prism. Okay, so you can measure, you can decide how you want to cut. You can decide, you got 3 pieces of paper on your things, you can borrow scissors around, you can decide how much you cut, you can plan before you cut, you can do whatever you want to do, long as you have a good conversation. The conversation should not be outside the classroom, should be about this. Now, at a final resort, as I want people start to think about a calculus discussion. How is the calculus come in play in here? But meanwhile, you guys can start by exploring like scientific method, which is experimentations, figure out what is the right length to cut, and find out what the volume of each thing. Like if 3 persons cutting different lengths, and would it give you a different volume? And you can compare, contrast. So a lot of things that you can think about all those little things, right? Little things. You have to figure out how to create the largest volume of the rectangular prism. The largest. Okay? Also, the SAT thing, if you can fill out for me, that's awesome. If you are interested about ping pong meeting, I'm thinking about just very straightforward, just like afternoon, like informal meetings, see like how people are interested. Today you're not gonna have homework for the first time or the second time in a row, huh? Or just I'm just gonna talk a little bit like if somebody I'm gauging interest of the people, like this afternoon. This afternoon. If you are interested, come in. Just come in.
You don't have
Yeah, no matter how you find it. No. So we have to figure out. Okay, so we have it's like so we have to figure out you guys decide. That's why you're so volume.
That's not fair. The right answer may not be the right answer.
But I feel I think we use the method we gave on the board. Right. Theoretical. So the paper. What's
Otherwise, you're not gonna
We all have the same.
There is U and L and W.
They're not using it like we'll start cutting. You can let the group use the scissor if they're not cutting. Scissors, scissors, they're not cutting. So cut the corner. Oh, by the way, this question's on your test on Thursday, so.
Yeah. No, we don't. Yeah, you're right.
I'm getting the whole thing.
Do you want like the length of the
So I put the width and actually it's not a too large one.
But you can develop this kind of recording conversation, then create a small montage, so.
Yeah, you can put that in the wall.
What do you guys think?
Rectangular prism. He didn't know we were going to do anything. What if it's all the same wall? Like, no matter how you cut it, you're doing the same, right?
It's a boss. Where's the top?
So the length is same above the length, and then right? When you divide the width, like when you get 5.37 right? So you
What do you think?
My mind is blank right now.
You cannot just invent it. You have to provide
I know. No, that's not.
Come back.
What be the conversation?
Yeah, I'm doing, you know, right now. It's like I'm just theoretical planning.
The only yes, but it's optimization, but it's not linear rate is based on time. So it doesn't have a time variable, but if you think in terms of other perspective, remember that question's the derivative respective circumference. That's a property something you know. Okay. Misha, what do you think? You can put it.
Are you gonna do that thing with people like hold it like?
Faith, what do you think?
Does anybody have?
You can follow.
Oh wait, does anybody have a?
Yeah, you can do that. But how do you decide like you know, I saw Instagram reel about this a while ago, but I should have never so I don't know what to do. You guys never stop doing Instagram reel. Right? Okay, so what do you think is gonna give you a bigger value? Higher base or like a taller rectangular person? Which one's gonna give you?
Move length for per height, then it's gonna add up to your
Yeah, well, I was just not. No, if we get just like. You just It's gotta be like, just like an actual. We're trying to find you to enter. It's like if you that kind of snap.
10 times 2 times. What do you think? And you made it 8.
Oh, you might be going out. So the bigger the more.
No idea.
You wanna try that? Yeah, what are you trying to do?
It's about.
But now having to measure it and be
Yeah, look, if you work on is it up? What? You have. You take 17 or what do you do like this? How you the derivative of the equation after plugging it in. You
there's some thing that's a little bit off, but it's fine. But this is probably the best I've ever seen in my life. It's the best.
They close the equal anything. You can
You got
We fixed
We fixed our problem.
you find out your problem?
Yeah.
Maybe you can show it nicely. What do you why do you
So
have a problem?
if it's
So these are,
20,
what amount are you tracking?
so if we have 2 centimeters squared, 8.
So you're subtracting, say we subtract 3 centimeters. That's 3 centimeters from this side. Yeah, so you have to subtract by.
Yes.
You have to subtract by something that's not.
I was messing
But what about whatever number you're attacking,
So what's but the problem is 28. And then multiply by
Each unit is 1 to 12 units. So they want to see that.
and then you just go. No. Because then you have a graph of how big it is. But then you don't know how big it is.
It looks crazy. You're right. Like maybe. Here to here, that would be.
Okay.
No, no, but it's like. Okay, it has to be. This one's just right. This one's right here. So you can almost like sketch it out like and then see how it would look like. It's not anything off. Anything off.
You know, it might be a good application, but you're back. He doesn't know what's the difference. You're supposed to cut off a square. I cut off the rectangle. I realize that now. Oh,
So we can all agree that the length of the side is equal to the original side minus the length.
Is that a straight line?
Yes.
I think you did
Minus this.
yeah, exactly. I don't know to back this up. Oh, just see the calculator, I guess, and just find where
Find the area.
if it hits zero, then you go.
The side times the side times.
No, we're taking this from here.
Right. One of the sides is C, one of the sides is the original side.
Yeah, what is this? What? Oh, that can't be right. You know that.
Oh, that's what I was.
You're in a blank. How can you be not above?
I think it's the one that you calculated. What, man? I'm thinking out that box.
I moved.
Yeah.
What do you guys think? I was like typing it
What?
All right.
No, I can do it. I can do it. I promise.
All right, so let me talk for a second. You keep on going. We're not showing a solution. We're trying to talk about different things about this question. Now, a lot of time, when the first thing I want to talk about is actually not involved with math, is about engineering. I told a story for every other period and every year. It's basically 1 year. I was about 7 years ago. I teach a group of students outside of school. They are like middle school. Like we're talking about 7th to 8th to 9th grade. And they are learning calculus with me outside of school during the summer. So what the situation was, I was in the room and I also invite all the parents to be in the room. So the parents could be in the room if they wanted to. I don't really care. So I will teach along with everybody to show that parents I know I'm talking about. So I remember there's one guy, there was one kid named Jonathan. Jonathan's dad is also sitting in the classroom. So Jonathan's dad just sit there and he's very quiet, very reserved. And he's like, he kind of raised his hand. He's like, since you guys, we already did related rate, we already did optimization. They just like chewed through it. They, how'd you guys call it? They ate it. 8 or whatever. So the 8th grade kids, they are phenomenal. They are phenomenal. So they go through related rate, shadow problem. They were no problem. They were just acing it each part. It turns out that his dad want to talk. He says, "Hey, Mr. Ye, would you mind if I speak on behalf of optimization?" I say, "Of course." Luckily, I didn't like put him down in any sort of way because I always learned to okay, make sure you respect other people. They cannot judge people by how they look or whatever. So he went up and he would start talking, and then lo and behold, he introduced himself. I'm glad I didn't do anything stupid. He introduced himself. He says, "I am Dr. Wang from UCF. I'm a civil engineer professor." Right? So I was like, oh, I didn't say anything stupid. So he says, "I would like to talk about optimization in terms of civil engineering understanding." So civil engineer understanding, so as an engineer, it's not a math domain that matter. So math domain is like this. Like for example, square root of on one of your homework on your test question, square root of 9 minus x squared. The domain is between -3 to 3, and this is called mathematical domain. For a civil engineer or as an engineer, the domain is actually not mathematical. It's actually called a physical domain, which is I never knew about this until I was listening to him talk. The physical domain is a big issue. Now imagine I have this piece of paper, right? The largest amount I can cut is what? What is the largest cut I can cut? That if I cut to that thing, I will not be it will not have a rectangular prism. What's the largest cut that you can do? Yes.
Overhead.
Which is what? In this case, we have 27 point what? 27.9 and what? 21.6 or 7? Okay. So what's the largest cut I can cut without not ruining the box? 10.8. And does somebody say like 13.85? It's 10.85 or 13.85 or 13.85, yeah. 13.9? Huh? 13.95 or 10.8, right? So which one is which? Imagine if you base on this side to cut, you're gonna cut way too big. You don't even have a paper left, right? If you cut more than 13, this is what's gonna be. There was nothing left. There's not even paper left. Do you see what I'm saying? Now, if you base on the small side, you can cut to here. You still have some paper left, but you're not going to be able to form a rectangular prism. Does that make sense? It turns out, I don't know, somebody in 4th period ended up decided to cut the largest square I can cut. They think that's going to form the biggest value. But by looking at this, which one's going to get bigger value? Not this one, right? This one's try to create a tallest one. You think about the tallest one's going to be bigger one. So think about this. One is the cut the most square space, and one of them is cut a little bit larger and different. This is the Allen's cut, I think 6 centimeter, and that's pretty tall. It's good, but we don't know what his volume is, Allen. And we also have different lengths of here, like different people are making different cut, which is fine. But let's talk about something first. The physical domain is between 0, it's going to be 2x, sorry. It's going to be 2x less than 10.11, 21.6. 21.6. So x is going to be less than 10.8. Is that okay? So this is going to be the things that you can cut. You can cut anything between 0 to 10.8. Physical domain, nothing to do with math. It has everything to do with the amount of paper. Most of you guys take AP chemistry. Raise your hand if you are. Okay, in AP chemistry, in terms of this, is called limited reagent. Have you guys learned about limited reagent? That means you have one side that is excess, and one side is the amount of material happen. The reaction can only happen based on the small amount. Does that make sense? based on a small amount, not based on a thing that's a lot more. That's really literally the think about limited reagent. In this case, that is the domain of the physical domain of the chemical reactions. Here is the based on the shorter side, it's 0 to 10.8. Does that make sense for everybody? Okay, good. Now, whatever we cut off, we're going to decide to name that as an X. Is that okay? And that's what we're going to name this as X, because we don't know how big we need to cut off. It's unknown. We don't know how big is it. X. We're going to cut off. Got it? Now, some people are going to cut different sizes. They're going to find out their volume is 600. Now, if you get anything over 1100, that means you did something wrong. That means your volume is going to be something wrong. If you get over 2000, which is that side and neither there, you get 2000. That means some calculations wrong and you guys fixed it, right? Okay, so what's your biggest volume now?
1053.
1053. Does anybody get bigger than 1053? What'd you get? 1074. 1080. 1080 as well. So I would say throughout everything, it's going to be roughly probably 1080 or 1081-ish. I don't know where exact, but we can find out how big is it. So how do we create... Guys, I cannot talk over you guys. How do we create the largest volume, but based on math rather than based on everything? So Gabby, you got to base on math. You cannot just say, I write down 3 numbers. Well, good. Your gut instinct is better than other people's. But we need a math to prove. We need a math to prove. Math still come in play. And Norman did the math at the very beginning. He started zooming now with the math and like a freaking math whiz and write down half-page calculations. And he found out the things. I think Ryden also come up with a solution using quadratic formula, which is very nasty. He used a math way. I actually have somebody using ChatGPT at third period. No. Surprisingly, that the way he asked a question is like, how do I find the biggest volume in 2D shape? And ChatGPT gave him the answers completely wrong because he didn't ask the question correctly. But you know, experience is experience. That you can ask ChatGPT. If you ask the right question, they will give you the right answer. But you have to know this is 3D shapes, not 2D shapes. So I don't know, like ChatGPT didn't tell him that's not possible because you're trying to form a 2D shape. But yeah, so a lot of people try different things, which is good. This is what a discussion is supposed to be happening, all this discussion. So how do I create this volume of this box? If you fold it, this is going to be this box, like this. Now this is going to be X. Does that make sense? The height is going to be X. What is the length and width? Yes, Kaden?
L minus X and W.
W minus 2x and L minus 2x.
Right. So it's going to be what? 27.9? 27.9? Was 27.9? Oh yeah, 27.9 minus 2x. Does that make sense? Because you cut off on each side. You fold it up on each side. And this one's 21.6 minus 2x. Does that make sense? Now, this is what Ethan has a problem with. How do you translate that to become a mathematical equation? And I thought, Ethan, you didn't think hard enough. But you had the right idea. How do you transfer that? Because you were thinking about graphing, which is good. He already think about the next stage about graphing it. But the thing is, he cannot come up with this equation. Is that okay? So now we come up with the equation. We says, okay, the volume is equal to x, which is the height. And 27 minus 9 minus 2x, which is that's the length. And 21.6 minus 2x. Does that make sense? That becomes a volume equation based on how much the cut is. The x is how much you cut, right? You cut out how big the square is. Is this okay? So what I'm going to do is I'm going to go in, I'm going to do this. Okay, so I'm going to graph this function. What the hell happened? So we're going to assign this volume of x right here is equal to x times 27.9 minus 2x. Is that right? And times what? 21.6 minus 2x. But it turns out I don't need a calculus to figure this out. But the thing is, you see a straight line. You're like, shit, I'm not going anywhere with a straight line, right? But we're going to start thinking about a physical domain. The physical domain is between what value and what value?
0.
So we're going to say 0, but I don't like to use 0 because I'd like to see the slack on the left-hand side. So I'm going to use a -1 rather than 0. And 10.8, I'm going to use 12. I'm going to see a little bit of slack. Now, great, I see 2 lines. And you say, well, at least the volume, we know the volume is going to be above 200, right? This line just keep on going up. We're going to see how far it's going. We can experiment the data. We can start with, let's say, 200. And obviously 200 is not enough. And we can experiment to maybe 600. We almost see the whole peak at now. And we're going to say, okay, let's go with maybe 1500. And then you got a really nice peak here. This is the peak, which is 4.02596, which is just right and use math way using quadratic formula. He got 2 answers, right? What's the other answer? Was 10 point something?
Like
13 point what?
13.3
13.3. What's the problem with 13.3? It's a past the physical domain. So that's why you need a physical domain for. That's why this can exclude the extraneous solution. Does that make sense? Am I going too fast? Now, what else happened? This is the actual graph. And you're like, wait, I could have just graphed this, yes. But the reason why we graph this is also looking at the derivative of the function. So we're going to type in a derivative function, which is v prime of x. Right, v prime of x. And we're going to just look at this. Now we're going to go back to what we learned before. Look at this. This is f prime of x. Where's the maximum happen? It went from f prime of x went from positive to negative. Do you see how beautiful it is? 4.02596. And do you see that minimum happened between 12.474? But that's just the outside of physical domain, but it's still worth to look at because let's look at original function. Boom. Right? Beautifully make that. You see the derivative of x, how they cross x-axis. That creates a maximum. Is that okay? And this part creates a minimum, which is also this point is 12.47404. That's the minimum. But that's outside of physical domain. But again, you're going to say, well, this volume is way bigger. Well, the problem is that's the function. That's outside of physical domain. This is no longer valid for this piece of paper. So there you go. There's your answer. Do you see how beautiful this is?
I didn't write.
I know you did. You had a. That's why I say, Bennett, that's the best I've ever seen you done.
What did I do wrong?
No, because you had too many variables. All right, so let's look at a second derivative graph. We're going to talk about second derivative tests.
No, I got it.
We're going to talk about second derivative tests. Okay, v prime of x. Now look at this. 8.25 is an inflection point because that's when the second derivative went from concave down to concave up. Do you see that? Look at original function. Does that happen over there? It happened at 8.25. I'm going to say 8.25 right here. Do you see that point? It's where it changing from concave down to concave up. That's an inflection point original function. Now, let's be even more impressive is look at that. The second derivative is negative. So it's concave what? Right? Maximum. Second derivative test. Do you see that?
Yes.
And look at here, second derivative is at 12.46 here is positive. 97.68. It's concave up. So that's why it's a minimum of the equation. We put all the thing into one picture now. We talk about physical domain. We talk about optimization. We talk about first graph. We talk about v prime graph. We talk about v double prime graph. They're all in the same picture. Let's put it all together. All three picture. The red line represents v, which is it can tell you the volume at any points. which is nice. I don't need to do calculation anymore. I can base on this graph, I can come up with the equation. That's called primary equation. And in this case, primary equation can take a derivative of that primary equation. Does that make sense? Do you see the math works? It like make every whole chapter of stuff into one image and went to one problem, went to one everything. We talk about second derivative test, we talk about first derivative test, we talk about inflection point, increasing, decreasing, concave out, concave down, all in one picture. I have a question, yes. It doesn't matter, but second derivative can test you if that critical number is 4.025, right? Is the second derivative is going to be below x-axis, it's negative. So it has to be concave down. So it proved that's a maximize rather than minimize. You could be minimize or this. Minimize of something, right? So it's not saying that this is a bad, just saying this is also a fair try. But fair try is actually not bad. A lot of people think about math is a fair try, it's a bad. Anytime you get a wrong answer, it's a process to getting the right answer. But a lot of you guys were frustrated after a fail. You're not supposed to be frustrated after a fail. You're supposed to be figure out what is wrong with my calculation. And that's how you lead to better mathematician rather than you are just owning the person memorize how to do a problem. There are a lot of people in this room, even if they get a good grade, doesn't mean that they are good at math. They're just good at memorize how to do a certain thing. I want you to be able to figure out. Bennett, on this hand, Bennett was a very good student right here because he actually figured out the equation. Now, he doesn't have better test score than Ethan, but Bennett, in this case, was better in this particular case. You can put it in the back. Oh, is the right triangle? Okay, cool.